In 1998, I was awarded a postgraduate diploma in optical fiber technology. After receiving that award, I went on to work in laboratories creating some embedded systems code. Embedded systems code to control various optical devices, such as step controllers. I wrote a lot of code after I received that award, but the embedded systems code I'm pointing to here as the start of my experience in creating embedded applications. An embedded application is generally an application that's tied to a specific device. It runs in a constrained environment. There are a number of challenges you face when you create applications for resource-constrained environments. Java has a framework known as OSGI that was developed to deal with precisely these resource constraints. The OSGI framework has been developed over a long period of time and has had a lot of resources from big companies, telecommunication companies, for example. More recently, we have this concept of a multi-platform application, and an embedded application can be part of a multi-platform application, and there are more recent developments with companies such as Gluon and JetBrains via their Kotlin programming language. These companies have developed multi-platform Gradle plugins that you can use to bootstrap and scaffold code for a multi-platform project. That is a project that can be compiled from one codebase for a desktop, a mobile, or an embedded systems application. In this series of videos, Embedded Applications, I will demonstrate these technologies. I created an OSGI application for a Swedish company called Tinko. The application, called ChargePoint, was used in charging stations for electrical cars. At each charging point in the charging station, there is a touchscreen display where we use the ChargePoint application to control and pay for electrical charging of your vehicle. The next application I will demonstrate is called Infusion Pump. It has that name because it controls a medical device called an infusion pump that has a number of pathways for delivering drugs to a patient in a medical context. This application was developed around 2017 for an American company called Medvis that produce medical devices. The final application I demonstrate is called Vitals Bridge. It is an interesting embedded application. It's not so much embedded, it's used to program dynamically a chip that's embedded in an ARM environment. It programs the chip via a protocol over Bluetooth. It was produced for the same medical devices company, Medvis.